Hi and welcome everyone to our lecture for the solar radiation and passive and active solar systems. So what is the difference between the passive and active solar system? The active solar system, let's use the laser pointer. The active solar system or the active solar energy system is simply used to provide heat energy or to warm up our house. So how can we do this? We use at first a component such as the solar collector. What does this do? This collects the sunlight or the sun rays, the heat energy inside the sun rays, collects them, and we have here pipes which contain a certain fluid such as water, for example, and this fluid will be subjected to heat energy due to the presence of solar collector, which collects all of the heat energy from the sun and provides it to the fluid inside the pipes. Now after this, the fluid goes through the pipes by using, of course, a pump which is fit inside it. Now we will find that this hot fluid, such as the water, you will find that it can be stored or it can be used as a heat exchanger with another fluid which is cold fluid, for example. Or for example here you will find that the hot fluid here exchanges the heat with the cold air inside the house. So the fluid here have the same temperature of the air inside the house. Then the heat energy presented inside the hot water tank provides heat for this cold one and makes it hotter using the heat exchanger. Then this one becomes hot and used to warm out or warm our home. So in the active solar system, we capture the energy from the sun by pumping a heat absorbing fluid such as the water or antifreeze through special collectors. So we capture energy by using a solar collector, for example, and pumping it using a pump, pumping this fluid such as the water or antifreeze through special collectors. We can also use the PV panels to collect the heat energy. Instead of using the solar collector, we can use solar PV panels, which is used to convert the solar energy into electrical energy. Then the electrical energy will be used to provide power to an electric heater inside our house. So we have two methods here of warming our house by using the electric heater or by using the solar collector, which provides power or provides heat energy to cold fluid. The collectors may be located on the roof in order to face the sun and collects all the energy from it. Some heat can be directly used and another heat can be used. Some heat can be stored in an insulated container with gravel, water, clay, and be used later. So we'll find here that we have here a water tank and we have here the heat exchanger to be used for to be directly used or to use the heat here directly inside our home. Used to heat water in many homes. This is the benefit of using the active solar system. Similar to the passive, the difference between them we will see it now. The passive solar system, you will find that this is an image of a passive. You will find that we don't have any components such as the solar collectors or PV panels. We don't have any of these components. But according to the construction of the building itself or the orientation of the building itself, all of this will help us in producing the passive solar system, which does not require any components as before. Now we'll find that the heat energy from the sun passes through the glass and contained inside our home. We have here different insulation layers in order to prevent the heat energy from going outside. So we use the heat from the sun, we pass the sun rays inside the house or inside the house and prevent them from going outside. Now the system absorbs and stores heat energy from the sun within well-insulated structure. The walls and floors are made of stone, adobe or brick or concrete. The water tanks used to store collected solar energy as heat and slowly release the heat through the day and night. So we simply use water tanks to store the collected energy and slowly releasing this heat throughout the day. Supplement heat with natural gas or propane heater. So we need here type of fuel in order to increase the temperature of the water itself, because this heat will not be enough to heat the water. So we need another type of fuel in order to increase the temperature of the fuel, of the water itself. So what is the advantage and disadvantage of these methods? The net energy is moderate in the active part and high in the passive. So the energy produced is moderate, medium amount of energy. However, the passive produces high amount of energy. Here the disadvantage is that we need access to sun 60% of time during daylight in order to, of course, collect all of the energy from the sun. Here is the advantage is that we have very low emissions of CO2 and other air pollutants. Now, why do we have low emissions? Because we don't have any type of fuel used, except in the case of the passive, where we use some amount of natural gas or propane in order to increase the temperature of the water itself. The disadvantage also is that the sun can be blocked by trees and other structures. So when the sun is blocked, it means that we don't have enough sunlight going to the solar collectors or the house itself. The advantage is that we have very low land disturbance because it does not contain any rotating parts. It does not contain any mechanical rotating parts. It is very silent process. We don't have anything which moves. The high installation and maintenance cost for active system, because we have solar collectors, we have pumps, we have solar panels in another case. So all of this will need maintenance and, of course, high installation at the beginning. The cost of the passive is moderate, but the problem is that we need backup system for the cloudy days for both of the active and the passive. Of course, how we can do a backup by using the natural gas or any other type of fuel. So the active and the passive systems are simply used in solar heating in order to provide heat for our house. We have two methods here, the active and the passive. One of them uses the solar collectors, the solar panels, and the other type does not use any of these. However, it uses the orientation and the construction of the building in order to provide heat energy to the water tanks or to the building itself. But in the course, we need to understand how we can generate electricity from the sun. So in order to generate electricity from the sun, we need solar panels. So we have to identify a very important term inside our process, which is called the solar radiation. So what does the solar radiation mean? The solar radiation representing the amount of solar energy which falls per unit meter square. So it representing the amount of kilowatt hour per meter square. So this is the definition of the solar radiation or the solar insolation. Now the sun itself have solar energy, 100% of the incoming solar energy, 60% of them is reflected by the atmosphere, 20% of the sunlight is reflected by the clouds, 4% is reflected from the Earth's surface itself, and you will find that 51% of the energy is absorbed by land and oceans. Now you will find that this is the percent representing 30% of the energy, which is reflected from the atmosphere itself, and the remaining goes absorption by the land, and part of it is radiated back to space. So the Earth receives 174 petawatt, or 10 power 15 multiplied by 174 watt of solar radiation or insolation at the upper atmosphere. So we'll find that this is high amount of power. 174 multiplied by 10 power 15. This is a very, very large amount of power, and can provide energy required for the planet for hundreds of years. So the solar energy itself is very important, and we have to benefit for this amount of power. So you will find that nearly 30% are reflected to space, while the rest is absorbed by clouds, oceans, and land. You will find that the reflection is 60% by atmosphere, 20% by clouds, 4% by the Earth's surface. So 6% plus 20% plus 4 gives us the 30%, which is the reflected. And the rest, a part of it, is absorbed by the clouds, the oceans, and lands. And very small is radiated back to the space. The spectrum of the light, which comes from the sun and reaches the Earth, which reaches here, is divided mostly across the visible region, the visible spectrum region, and near the infrared ranges, and a very small part in the ultraviolet range. So our light have 3 parts: visible, infrared, and ultraviolet. Of course, this is the one which passes to the Earth. But of course, we know that the light itself is having a large spectrum containing the radio waves, for example, the X-rays, the gamma rays, and etc. According to what? According to the type of the wavelengths and frequency. So according to the wavelengths and the frequency, we can identify it as a radio, or visible, or infrared, or ultraviolet, and etc. So the solar energy, or the light energy here, or the photons of the light, is divided into the visible spectrum, having some in the infrared and small part in the ultraviolet range. Most of the world's population live in areas with insolation of 150 to 300 watts per meter square, or 3.5 to 7 kilowatt hour per meter square per day. So we'll find that the insolation here is similar to the solar radiation. The solar radiation is similar to the insolation. The insolation representing the amount of power received per meter square, or amount, to be more specific, the amount of energy received per unit area. So we'll find that the insolation can have 150 to 300 watt for each meter square, or 3.5 to 7 kilowatt hour per meter square. This what depends on the position or the coordinates of the point in the Earth, and we'll understand how to get the amount of solar energy, or the kilowatt hour per meter square, for any region inside the planet. Now we will find here an example of the PV planet. You saw before in the previous slide the PV, the solar radiation, or the solar insolation, or both of them are similar to each other. The amount of power which can be generated from the sun, 174 petawatt, is provided by the sun. So we have to make or use this amount of power. So we have, in order to do this, we need to use the solar panels to collect the solar energy into electrical energy. So we'll find here an example of the PV plants, photovoltaic plants. This one is, for example, 2.2 gigawatt in India. This one you will find thousands of the solar panels in the desert. Okay, this solar panels, all of these solar panels produce power which is nearly equal to 2.2 gigawatt or 2200 megawatt. Another one in Abu Dhabi, 1.1 gigawatt. This one is also in the desert, because in order to benefit from the sun, and of course the desert does not have any population, so we start using this empty area and benefit from the sun, which is called here, this one is called the Noor Solar Park. Another one, PV plant in Japan. This PV plant, you will find that the solar panels here are installed in the ocean, okay, or in the sea itself. They are all on the water. We take the advantage of the presence of the free area or open area and add solar panels to it to collect the sunlight which falls on the water itself. Now the PV panels, this PV panel or solar panel, how it looks like. The PV panel looks like this. It have different types as we discussed in the course. We have the monocrystalline, polycrystalline, the thin film, and etc. Now you will find that this panel, for example, have the width, certain width, and certain height, and certain thickness. So the configuration of it, you need to know, of course, the length or the width and height and thickness. Why? Because when we install on a roof, we need to understand the amount of area available, and when we know the amount of area available, we will know the amount of energy which we can generate. This is the front of the panel. The back of the panel, you will see that here it consisting of diodes which are installed in the junction box, which we are going to discuss. The diodes here is used to prevent the current from going in the reverse direction at night, for example, from the batteries to the panel. And we have here two cables going outside from the panel, one of them representing the positive and the other one is the negative. This one, which is the male, is the positive, and the other one is the female and negative. This cable is 35-inch cable and called as and with MC4 connectors. Okay, and we'll see the MC4 connectors in the next slide. Now we'll find that here we said now the advantage of the diodes to prevent the reverse direction of the current to the panel itself. And we have the two cables which is used to connect the panels together in series or in parallel. Now we will find here that this, of course, is the male and female, the positive and the negative, which comes out of the junction box. So this one is the junction box which contains the diodes and the two terminals of the panel itself, positive, negative, and of course the panel itself have a certain amount of power. It can be 50 watt, 100 watt, 150, and etc. according to the wattage of the panel itself. Now we have the positive and we have the negative. Now in order to connect them in series, of course we connect the positive with negative of another panel, and the positive of another panel is connected to the negative, and etc. as we discussed in the series and parallel connection of the panels. And of course if they are in parallel, then the positive with the positive and the negative with the negative. Now someone will tell me that how can I connect the positive and the other positive together? Yeah, for example, what I mean is that we have for example this one. Okay, this one, you will find that this one is the positive, as you see here, the positive and the negative, and this one is positive and the negative. Now for example, this one is a panel as an example, and this one is another panel. Now I would like to connect these two panels together in parallel, not in series, in parallel. If I would like to connect them in parallel, then the positive should be connected with the positive, positive with the positive, and the negative with the negative, right? Because we are connecting them in parallel. But you will find a problem here, is that the negative here and the negative here, both of them are females. Okay, you will see that this negative and this negative, both of them are equal to each other. And this one is positive and positive. So how can I connect a positive with another positive or negative with another negative? By the usage of the MC4 connectors. These connectors, when we provide, for example, the female, for example, we connect the female here and it provides us a male. So what I mean is that we can connect the female to this connector to provide a positive or the male. So for example, here you will see that this one is the negative and this one is the positive. Now I can connect the negative here, the female with this one, and we can take this terminal to provide the male required. Okay, for example, if I would like to connect the positive with the positive, therefore how can I do this? By connecting this one to here, to the female, and we will have a male. Okay, you know that the vice versa of them. So for example, if I would like the positive, then I will connect the negative here with this part to provide the male. Okay, so simply we can by using the MC4 connectors, we can provide the male and female as I would like, and I can connect them together. Now the panel itself can have a different wattage and according to its power. You will find that this is available in market: 50 watt, 100 watt, 150 watt, 200 watt, 250 watt, 300 watt, and 350 watt. So this is an example of the panels available in the market. And you will find that as the wattage increases, the size of the panel itself increases because we increase the number of cells inside the panel in order to generate more power and collect more solar energy to convert it into electricity. Now here you will find an example about the solar panel. The solar panel here, you will find the module type. Okay, this one have a maximum power at STC B maximum, the maximum generated power of the panel, the maximum output power of the panel is 250 watt. And you will find that is at STC. What does STC means? It means the standard temperature conditions. So what does this mean? It means that we are operating at an irradiance, or the solar insolation, or the amount of radiation is 1000 watt per meter square. And at the same time at a temperature of 25 Celsius degree and air mass of 1.5. The air mass will be discussed in the shading and tilt angle lecture. So for now you will find that the maximum power of the panel, this one for example 350 watt, is the maximum power generated at these conditions of 1000 watt per meter square radiation from the sun, temperature equal to 25 Celsius degree, and air mass 1.5. Now we will find also the open circuit voltage and short circuit current. So what does this representing? This representing the open circuit voltage of the panel. Okay, when we measure the between the two terminals of the panel, the voltage between them at no load case, when we are not connecting any load, the open circuit voltage, the maximum voltage between the terminals of the panel is 37.5. And the short circuit current of the panel, the maximum current which can flow inside the panel, is 8.87 ampere. So what does this represent? This representing the, when we have the let's see the two terminals, for example this panel, we have positive and negative. When we measure by using the avometer, the voltage between positive and negative, you will find that this one is equal to the open circuit voltage. And when we provide a short circuit between them, using the avometer, for example, when we provide a short circuit to the panel, the short circuit current flowing inside the panel is 8.87 ampere. This is the maximum output voltage. This is the maximum current or the short circuit current of the panel, the maximum current which can flow inside the panels. Now we will find here the optimum operating voltage and optimum operating current. So what does this representing? You will find that this voltage is 30 volt and this one is 8.3 ampere. You will find that this value 30 volt and this open circuit is 37. The current is 8.32 and short circuit 8.87. So this value is of course lower than this. So this value is representing the optimum operating condition. So what does this mean? If we can produce a voltage of 30 volt across the panel and the current absorbed from the panel is equal to 8.32, then in this case we will provide the maximum power. Okay, so when the panel voltage and the current equal to 30 volt and 8.32, we can provide the maximum power of the panel. So what is the maximum power of the panel? Is that 250 watt. So the 250 watt can be achieved of the panel if we have a 30 volt and 8.32 ampere. Okay, so if we draw the power curve, okay, like this, you will find that the power of the panel like this. This can be achieved at a certain voltage and a certain current. Okay, so the value of the voltage and value of the current is 30 volt and 8.32 ampere. Now you will find another thing here, the laser pointer. You will find the temperature coefficient of the power maximum. So what does this represent? It means that the power maximum, the maximum power which is 250 watt, will be reduced for each Celsius degree by 0.44%. So minus 0.44% representing the reduction in percentage of the power or of the maximum power for each rise in temperature. So the power maximum here is generated at the 1000 watt, temperature 25 Celsius degree, and air mass 1.5. Now you will find that if the temperature, for example, instead of 25 becomes 26 Celsius, we increase the temperature by 1 Celsius. What will happen in this case? The power maximum will be reduced by negative 0.44. The power will be reduced. And the temperature coefficient of the voltage and the current, the voltage will also be reduced by 0.3%. But the current, if the temperature increases, the current will increase by 0.04%. So we'll find here the effect of temperature. If the temperature increases by 1 Celsius degree, then power maximum reduced by 0.44%. V open circuit reduced by 0.3%. I short circuit will increase by 0.04%. Now we will find that the maximum system voltage, which happens when we connect a group of panels together in series, the maximum system voltage is 600 volt DC. This voltage, where did we get this value? 600 volt, which is in the data sheet. This value is from the NEC code or the National Electric Code. The National Electrical Code says that the voltage must not exceed 600 volt DC, or the panels which is connected in series should not exceed a voltage of 600 volt. Now you will find that the maximum series fuse, the fuse which can be added in series with the panel as a protection for the panel, the maximum fuse is 15 ampere. You will find also the weight and the dimensions and etc. So this is the specs or the specification of the panel itself. And we see that the panel itself and the effect of the temperature as we discussed in another lectures. Now the solar electricity systems are given in a rating in kilowatt peak. So when I am talking about power plant, when I say 1 megawatt, I mean 1 megawatt peak. So what does this mean? It means that the maximum power which can be produced. So the plant or the PV plant can be measured in megawatt peak or kilowatt peak if it is a small PV scale. This is essentially the rate at which it generates energy at peak performance, for example at the noon on a sunny day. So at the noon on a sunny day we have the maximum power which can produce from the sun, which is the time at which have the maximum amount of irradiation from the sun. So this time representing the maximum power which can be generated, and this one is the one which can represent the capacity of our solar PV system. The kilowatt peak of a domestic system will vary depending on how much customer wants to spend, how much it will spend on the equipment, such as of course the panels, how many panels can he pay for it, the inverter size, charge controller, and batteries, and of course the roof area available in order to install the PV panels. We can also know the radiation of an area, the required tilt angle of the PV system, the tilt angle representing the inclination of the PV system, and temperature, of course, which is the temperature at which the panel will be installed, by using the Global Solar Atlas. The Global Solar Atlas will help us to identify the radiation of an area, the tilt angle, and the temperature, as we will see now. By using the Global Solar Atlas website, we can get these values. So let's go to the Global Solar Atlas website in order to find this and see what is the information available for us. Now, if you type in Google Global Solar Atlas, you will find that this website, which will give you information about the heat energy, or not the heat energy, of course, the solar energy in the different parts of the world. Now, as an example, you can move here and see the full map, as you see here, at any region you would like. Okay, like this. Now, for example, let's see this area, for example, here in my own country, Egypt. If I, for example, select this one, click here, one click on this area, double click, and you will find that this is the name of the area which I selected. You will find here the specific photovoltaic power output, the power output from the photovoltaic specific, which representing, what does this represent? Representing the kilowatt hour or the energy generated per kilowatt peak per year. So what does this mean? It means that each 1 kilowatt peak installed will provide us 1893 kilowatt each year. So in one complete year, I can, using the 1 kilowatt installed, 1 kilowatt peak of panels installed, can provide me a power of 1893 kilowatt. Okay, so this is simply can provide you with the energy required, or the energy can be produced from a certain area. Now you will find that here we have the direct normal irradiation, the irradiation or the solar insolation with the different definitions. The irradiation here is 2211 kilowatt hour per meter square. So this representing the energy produced for each 1 meter square. Now you'll find here the air temperature, the temperature in this particular region, 221.1. The optimum tilt angle, which is the one which is important for us, the optimum tilt angle. So what is the angle which should be provided? 30-degree angle which can be provided. Okay, and assuming here that the elevation of the panels is at 120 meters. So of course, according to the specs, you can know the region. Now, the thing here is that you will find that by selecting another region like this, you will find a different powers. The power here, for example, 1986 kilowatt hour per kilowatt peak. Now, what I would like you to notice here is that there is a different colors inside this map. So you'll find that the blue one is the lowest one, and the darker the color, the more energy which can be produced. You will see that the blue one, 600 kilowatt hour per each kilowatt peak installed. This one is the energy generated for the blue in 1 year. As we go darker to the maximum, which is 2400 kilowatt hour per kilowatt peak in 1 year. So you'll find that this one is a dark color, which is in this region, 1986, okay, in the range between 2000 and 1900. Now, if we get a brighter one, for example, this one, like this, you will find 1396. If we get a dark one, like this one, you will find that 1900. So as the color goes darker, it means that we can provide or get more energy, or more energy can be yielded from the sun. So what is the benefit of the Global Solar Atlas? Here you will find that the Atlas provided you with the different PV power which can be produced according to the position inside the world map, gives you the estimated amount of kilowatt hour produced per kilowatt peak installed in each year. Not only this, but also provides you with the regions which have higher amount of energy. Not only this, but also provides you with the optimum tilt angle of the PV modules. You will find that in another lectures we discuss different methods of obtaining the tilt angle. Now you can get the tilt angle easily by using the Global Solar Atlas. It provides you directly with the angle required of the PV panels. So in this video we discussed the different types of the solar heating methods. Then we discussed the PV panel, some specs about the PV panel, and finally the Global Solar Atlas.